Welcome to Notes 9.07. Here on the screen, you can see the video that I hope you've watched already. I'm going to play it for a second.
Sign, opposite hypotenuse, sign, opposite
So this
hypotenuse.
acronym SOHCAHTOA, you can read it up in the top left corner. SOHCAHTOA stands for sine, cosine, and tangent, SOHCA and TOA. And that helps us remember that sine is a ratio from the opposite side to the hypotenuse in a right triangle. Cosine is going to be your adjacent side to it, the hypotenuse, and tangent, opposite, adjacent, tangent. So when we look at the right triangle, we have three sides. We always have the hypotenuse, which is opposite your right angle. We will also have, from what angle you're focused on, the opposite side. From your opposite side and your hypotenuse, you have one left over, it's going to be your adjacent side. So those are going to be important as we're trying to set up our trigonometric ratios. So going back into my notes, and again, you're also going to need your graphing calculators today, and I want to start there. We need to change the mode of our calculator to make sure that we're measuring angles in degree mode instead of radians. We'll find out what radians are more in our next unit on circles, unit 10. But for right now, if you go to mode, go and highlight degree. That'll change it way up at the top of your screen. You can see it says degree mode, so you know you're in the right option. And if you just want to test typing in cos, C-O-S, that's just the three letters that stands for the word cosine. So you're going to hear me switch between cosine and cos a lot, and tan versus tangent. It means the same thing, it's just its abbreviation. But if we type in cos 50, we should all get the decimal equivalent of 0.6427. So all of these are ratios. So cosine of 50 is 0.6427. If I typed in sine of 30, we actually find it to be perfect, 0.5. So sine of a 30-degree angle, we're going to find out, is half, or 1 over 2. So those are ratios. How we use them is to calculate sides and angles in a right triangle. So looking at triangle CAP here, we have CA being 10, CT being 5, and the hypotenuse, AT, we don't know. We're going to find that to begin with here. Going back up, I'm going to explain what SOHCA and TOA are in part 2 of this exercise. But again, the acronym COH stands for sine of an angle is opposite to hypotenuse, cosine of an angle is adjacent to hypotenuse, tangent is the opposite over adjacent. So again, those are ratios of measures on sides of a triangle. So for triangle CAT, we're going to evaluate the three trig functions and of angle theta. So that symbol there, this kind of curlicue, is called theta. It's a Greek symbol. It's just a fancy way to say x. But before we can evaluate that, we do need to find the third side here. So we're going to use our Pythagorean theorem, a squared plus b squared equals c squared, to find our hypotenuse c. So since this is a right triangle, and we're in right triangle trigonometry, we can only use these trig functions when we have that right angle. So our side c is going to be 5 squared plus 10 squared equals c squared. X squared is 25 plus 100 gives us 125 equals c squared. We are going to find this in simplest radical form, just looking ahead for question 1. Square root of both sides gives us square root of 25, jumping ahead, times square root of 5 will be 5 radical 5. It's going to be the measure of, the side x here. So now we know that that's 5 radical 5. Now, we need to focus on angle theta. So this theta, again, is just saying that we don't know the measure of angle A, but that's the angle we're focused on today for this question. From that angle, again, the 5 radical 5 is your hypotenuse, but we need to identify what the opposite side and the adjacent side are. So touching the angle is the side of 10. That's going to be your adjacent side. We have the hypotenuse again, which is always across from the right angle. So if we have the adjacent marked, the hypotenuse marked, the third side has to be our opposite. When we're focused on angle A, we have opposite, adjacent, and the hypotenuse. So let's start with the sine function. I'm going to find sine of theta equals the opposite side over the hypotenuse. So its opposite side is 5, and the hypotenuse is 5 radical 5. You can't leave this like that. So when we have these radicals, we are going to have to rationalize. So in that case, we're going to multiply our fraction here by radical 5 over radical 5. So we get that sine theta equals 5 rad 5 in the numerator. And our denominator, remember square root of 5 times the square root of 5 here is just a 5. So 5 times 5 gives us 25. Last but not least, we're going to simplify. So we get sine theta, and 5 goes into 25 5 times. So we have square root of 5 over 5. So we couldn't leave it as that first option because, again, the denominator had a radical. So sine theta equals radical 5 over 5. That's the ratio to represent angle theta. We're going to go through the same process to find cosine of theta. So cos theta equals the adjacent side over hypotenuse. So from the angle A, the adjacent side is 10, its hypotenuse is 5 radical 5. So I put 10 in the numerator, 5 radical 5 in the denominator. And again here, I'm going to have to rationalize. So I'm going to multiply by the radical 5 over the 5. So we have cos theta equals 10 square root of 5 over 5 times, and again, radical 5 times that radical 5 becomes 5. So 5 times 5 is 25. So simplifying, 10 and 25 are both reduced by 5. Goes into 10 2 times, and into 25 5 times. So we cos theta equals 2 rad 5 over 5. And the last option is actually kind of easy. Tan theta equals opposite over adjacent. So that's the TOA, T-O-A. So the opposite from A, again, was the 5. The adjacent is 10. So we can write tan theta equals 5 over 10. So this question was just asking us to evaluate 3 trig functions of angle theta in simplest radical form. So step 1 is done. Moving on to actually using these trig functions to find sides of a triangle. So again, trigonometry is used to find sides or angles of right triangles. Again, that's important for us. So the steps here, circle the angle, because that's what we're focused on. We're focused on that 70-degree angle. Label your O, your A, and your H, your opposite side, adjacent, hypotenuse, and then decide which trig function. So that acronym, SOHCAHTOA, S-O over H, is cosine is A over H, and TOA is T-O over A. We are going to be forced into one of these 3 options based on the measures that they give you in the diagram. So from our angle in exercise 2 here, we have the opposite side being x and our hypotenuse being 12. There's nothing next to the adjacent side. So since there's nothing next to the adjacent, we're going to eliminate cosine and tangent as options here. So we're going to set up a sine function. So sine of the angle, so the second piece there is always the angle measure. We were using theta in the last question. because that was the measure of the angle we didn't know. Now we're putting in a degree here. So sine theta equals opposite x over hypotenuse 12. So here's our trigonometric ratio. This is when we're going to start evaluating. So we can set up a proportion and use cross products to find the value of x. So again, here we have a proportion. So x equals, and when we cross multiply, I'm going to put the 12 first times sine 70. I'll explain why in the calculator here. And we need to make sure we're solving, and didn't indicate, but I'm going to decide that we're going to go to the hundredths. So going into the calculator, we're going to type in 12 times sine of 70. Remember, sine of 70 is some decimal equivalent, which is irrational, times 12 gives us about 11.27. And looking in the diagram, that makes sense for the context of this question. This side, x, that we're looking for should be shorter than our hypotenuse, so we're good. So x is going to approximate to 11.2, and going back up to check the decimals, that 6 is going to bump us up to the 7 up to an 8. So 11.28 is the measure of side x. So again, going through our 3 steps, circle the angle, decide the trig function, after labeling your opposite, adjacent, and hypotenuse. So looking at exercise 3, circle our angle 50 degrees. We're given the adjacent side. We're given the hypotenuse. So adjacent hypotenuse is a cosine function. So we're going to write cosine 50 equals the adjacent side 6 over x. And this one's a little tricky. The little hint I have is that x in the denominator means division. We're going to divide something. Okay? So when we do our cross products here, we get x gets multiplied by cos 50, x times cos 50. And we could find out the decimal. It's actually a little bit more work for us to write that out right now. But when we cross multiply the other direction, we get a 6. X isn't standing alone in this case. Here, when x was in the numerator, when we just cross multiplied, x stood alone. But now we need to divide by cosine 50. So we're just going to treat it almost like a variable for a second. So when things are being multiplied, we undo them with division. So that x equals 6 divided by cosine 50. Now, in the calculator, when we type this in, 6 divided by cos 50, notice every time you type a trig function that opens a parenthesis, we do like to close those. I forgot to mention that in the first case. It's almost automatic for me. But 6 divided by cos 50 does give us an approximation of 9.3 into 100. We're going to round to 3. So looking at the diagram, that does make sense for the context here. This is our hypotenuse, is x, should be longer than the 6. So 9.33 is a sufficient answer. So that's setting up trig functions, finding a side. We're going to jump right ahead into finding an angle. So again, there's 3 different digits that can go into these setups. We have the trig function, the angle measure, and then 2 side measurements that we typically have. So in the next couple cases, we're going to solve for a missing angle. So when you're looking for an angle, we're going to circle the one we need. Again, we're going to label our O, A, and H. And when looking for the angle, we're going to use sine to the -1, cosine to the -1, or tangent to the -1, depending on the trig function. And to get there, you use the second button, and then your trig function. You mean sine, cosine, or tangent. So something else, this DMS stands for degrees, minutes, and seconds. That's just a more specified value of your angles. So we'll go there when we type this in here in a minute. So for the right triangles below, find the measure of each angle x. So again, we're going to identify the angle. On that angle, we have the opposite side, we have the adjacent side, nothing next to the hypotenuse. So we're going to use our tan function. So tan, again, the angle goes here, it's x equals 3 to 4, opposite adjacent. And again, to solve for the x value, we can't use cross products. You essentially would have to divide tan over. So what happens in your calculator is you get that tan to the negative 1. So the next line is always going to read, when you're finding an angle, x equals the trig function to the negative 1 power of the fraction, the ratio 3 over 4 in our case here. So into the calculator, we turn it on, and you clear out what I have, and you're going to hit your second button first. So sin to the negative 1, close to the negative 1, tan to the negative 1 is in that blue right above each button. Tan of 3 divided by 4 gives us this degree measure, 36.869. So x as an angle is approximately, and I'm going to write this out to 4 decimal places. So roundings can be important here. So you're going to need one answer to get other answers later. We want to be as precise as possible. So here, if I write this out 4 decimal places, if I use right into the hundredths, so the tenths, I'd have enough places to go. But in this case, we're going to look at a new type of measure, which is minutes and seconds. So just like you kind of calculate an hour down to the minute and the second, you can do the same thing with these angles. So in your calculator, you're going to hit second, apps, and you can see the word angle right above apps. So second, apps, and we're going to go to choice 4. What that's going to do is that little arrow says convert to degrees, minutes, and seconds. So when we type in 4, it's going to take our angle measure and change it into 36 degrees, 52 minutes, and 11 seconds. Now when rounding, this minutes, it doesn't go by 100 like we usually count out of 100. It's going to go out of 60 seconds. So anything above 30, our minutes, anything above 30 would round up the degree measure. So same with the seconds, if that's 11 is 30 or higher, it's going to round up. And that little reminder is here on your page. 30 minutes, round up, 30 seconds, round up. So if we have to go to the nearest minute, we're going to have 36 degrees and 52 minutes, because 11 is not going to round us up at all, so the seconds to round up your minutes. We're going to do another one. So moving along, we have x as our angle, and from that x, we have the opposite side being the radical 3, the hypotenuse being 3. So opposite hypotenuse is sine of angle x equals opposite rad 3 over 3. And again, when finding our angle right next to our trig function, we automatically go to x equals sin to the negative 1 of square root of 3 over 3. So going into the calculator, we hit our second button to get the negative 1. Square root of 3, and make sure you come out of your radical before you divide by 3. There's some parentheses this time. We get 35 degrees and about 0.3 here if we're just talking about decimals and rounding to the tenths place. But again, we're going to round to the nearest minute. So we're going to go to second, apps, choice 4, change our answer to degrees, minutes, seconds. And here our seconds are above 30. So it's 35 degrees and it's going to be 16 minutes. So x is approximately 35 degrees and 16 minutes. Move that little symbol up some. It's kind of like a dash mark, almost like a feet symbol. But we're talking degrees, so we know it's minutes. Moving on to solving a triangle. We have to solve a triangle. Okay, so here it says solve triangle ABC, the directions. It means to find all 3 sides and all 3 angles. So notice we have capital letters on purpose, always next to our next to our vertices is what I'm looking for. And the lowercase letters are the sides opposite each of those angles. So across from angle A is little side A, across from angle C is little side C, and that's really where we think of as the hypotenuse when we're using our Pythagorean theorem. So looking at number 5, solve triangle ABC with right angle C. So we're going to start with a picture. We're going to put C at the right angle. And angle B is 24 degrees. Now I'm going to put my B up top because that looks smaller than my angle A down here. And drawing things a little bit different from time to time helps you guys see it. So 24 degrees there goes there. Now we would know what angle A is because we can take 90 and subtract 24. They're going to be complementary. So we get 66 degrees. So far we know that angle A is 66. It's one thing we have to find. Again, when we're solving the triangle, we find all the angles and all the sides. Moving on to the sides, letter A is 8. So from A, opposite angle A is going to be 8. And we need to find little b, which is down here, which is side CA. And we need to find the hypotenuse, little c, which is across from letter C. So again, we're going to decide a trig function because right now we don't have two sides. So again, remember this is a letter B, not a 6 down here. We don't have two sides, so we can't go to the Pythagorean theorem quite yet. But from here, we are going to focus on the 24. Now you could focus on the 66 if you wanted, but I'm going to start with the 24. 8 is the adjacent side. C is your hypotenuse. And B is going to be the opposite side. So I'm going to start with the tangent function, and I'm going to find little b first. So side B, or here, and again, we're going to use the tangent function from the 24-degree angle equals opposite side B over the adjacent side A. So opposite adjacent. And cross multiply, B equals 8 times tan 24. And again, since we're finding a side, we do not use the second function this time. We simply just type 8 tan 24. Notice this time I left out the multiply sign. 8 next to tan 24, the calculator knows to multiply. So rounding to the nearest tenth, B is approximately 3.6. Now, let me step back a step. I would like you to get in the habit of writing out all 4 decimal places. So again, 3.5618 would then round to side B being 3.6. These 4-digit decimals are going to be important when we do other things later in this unit. So again, if we can get in the habit of writing that down, let's start with that today. Last thing we need to find is side C. Now I'm going to try to avoid using an answer I've already found. So I'm going to go back to the adjacent side, C being the hypotenuse. Adjacent hypotenuse is going to be cosine from the 24-degree angle equals the adjacent 8 over side C hypotenuse. The reason I don't want to use one answer to go to the next is that rounded answer is going to affect my next one. So I like to go back to the original values if possible. Cross multiply to get C times cos 24 equals 8. C isn't standing alone yet, so we're going to divide by cosine 24. And C is going to approximate to with 4 decimal places. 8 divided by cos 24 gives us 8.7570. So side C is going to round to 8.8 as the tenth place. For some reason that doesn't sound right. Now, a little check I'd like to do here is we could decide that a squared plus b squared does equal c squared. So just to verify that the numbers we're finding are correct, if I were to put in 8 squared plus side B, this is 3.5618 squared. We can find that sum, a squared b squared equals 76.68. Now if we square side C, and again I'm going back to those 4 decimal places because those are the most precise answers we have, we can verify that a squared plus b squared does equal c squared. Now again, had I gone out more decimal places, these would have been a little bit more precise. Last thing we're going to kind of fast forward to here is some word problems. So there's 2 vocabulary words that we're going to look at is the angle of elevation, and the angle of depression. So looking at these two diagrams, angle of elevation you can think of as looking up. Angle of depression is an angle looking down from somewhere. So looking at this little guy here, if they were to refer to angle of elevation, we're talking about an angle from the ground looking up toward the top of this tree. But that angle would also equal, if I come out and say there's a bird on the top of the tree, okay, really bad bird drawing there, but his angle of depression would be equal because of our alternate interior angles. So the angle of elevation and the angle of depression are equal to each other. From here, the guy up at the top of the lighthouse would be looking down at a boat on the ground. So that angle of depression is outside the triangle. But remember that angle X would repeat down and inside with using your alternate interior angles. You can also look at some complementary angles. So X is here, 90 minus X would be in here. So if we had a 30-degree angle outside, we'd have a 60-degree angle inside. And sometimes we're going to view things from a little bit different angle as you draw your own diagram. Exercise 6 is a word problem. 27-foot-long wire stretches from the top of a vertical pole down to a stake in the ground 21 feet from the foot of the pole. So if I draw a pole here, we're going to know that the pole is perpendicular to the ground, and we should have some wording in there to usually tell us that, but we're going to make an assumption today. So 27-foot-long wire stretches from the top to a stake in the ground. So if there's a stake in the ground here, like a telephone pole, that wire is 27 feet. And the pole is 21 feet from the foot of, the stake is 21 feet out. And to the nearest minute, so we're going to have to convert to degrees, minutes, seconds, to measure the acute angle the wire makes with the ground. So if our wire is here, now you'll see our ground is at the bottom, we're looking for angle X. So from that angle, we have the adjacent side and the hypotenuse. So we use the cosine function, again, X equals 21 to 27. Again, finding an angle, we automatically go to X equals close to the negative 1, 21 over 27. And I'm going to go to the calculator. I'm sorry I'm kind of speeding up here. I feel like we're getting a little long in this video. So second cos 21 over 27 gives us the degree to the nearest tenth place, but again they ask to the nearest minute. So second X, and you can arrow down to choice 4. I've been hitting number 4, and it jumps me there a little bit faster. And enter. And this X is 38 degrees, 56 minutes, and 32 seconds. So here, again, that 30 is going to bump us up by 1 minute. So our final answer is going to be 38 degrees, 57 minutes. Okay. Now, if you'd like to try number 7 on your own, I invite you to do so. I'm going to give you the final answer here. Should be 190 feet. When you have to type in your 29 degrees and 40 seconds, let me just show you 29, and in your angle menu, you can put in the degrees, and then the 40 seconds, you would type 40, second apps, and put in your second apps. There we go. Second, there we go. So choice 2 is the minute. So that's how you type in 29 degrees, 40 minutes when you try the question here. Final answer again should be 190 feet. I invite you to try classwork 907 first. I would like you to email me a picture of the front of the classwork. You're going to skip number 10 and also try the homework 907. But I would try the classwork first. It's a little bit more direct. Thank you. Have a great afternoon or evening or morning whenever you are.